I'm going to take a look at constant current sources, CCS. A constant current source has the purpose of delivering a known current to a circuit. The current generator, which looks like these two circles joined together, is connected in parallel to an internal resistance Rint. The current source represents the magnitude of the current supplied, and the resistor represents the internal resistance of the source. For a current source, the value of Rint should be as high as possible. If we consider the current source below, here we have no load conditions on the left and load conditions on the right. Under no load conditions, all the current, for all intents and purposes, bypasses Rint, which gives us a condition where the output current, I out, is going to be equal to the magnitude of the supply current. Taking a look at the condition for the load, where the load, RL, takes part of the current through the circuit, our condition would then be I naught is equal to I minus IR int. You might recognise as having the relationship to Kirchhoff's laws. So if we now take a look at an ideal current source. In an ideal current source, the internal resistance should be as high as possible, which means that we can kind of represent it as if there is no pathway down here. So where the current source Rint, where Rint was on the current source, if this is a very, very high resistance, then the majority of the current will go this way, so we can assume the circuit would then look like this. And under no load conditions, well, the same thing applies. I naught equals I. And under load conditions, well, we get the exact same condition. So under ideal conditions, the value can be considered to be infinite. We can see here the value of the output current will always be the same then. So the value of this output current here will always be the same irrespective of the load state. This therefore supplies a constant current source to any load condition, and that's what we call a constant current source. If we take a look at a quick example which might make this a bit more helpful. We have a current source on the left hand side with a magnitude of 5 amps. We have a load of 10 ohms. Taking a look at our output, Vout is going to be equal to 5 times 10, which gives us a 50 volt drop across the 10 ohm load right here. So there's going to be a 50 volt drop across these two terminals either side of the resistor. Our current stays the same. Similar vein on the right hand side, 5 amps with a 5 ohm load. Our output voltage drop across the terminal of the load would be 25 volts, which means that we have a changing condition related to the voltage rather than the current. So as the load changes, the voltage produced across the load changes, but the output current remains the same. So a constant current source is therefore defined as a device that supplies a constant current to a circuit irrespective of the load across it.